of attendance and the slides recording. So just make sure that at the end of this session you scan the QR code. I'll share the link as well in order for you to receive the certificates of attendance. Just note that you cannot be able to get the certificate of attendance if you haven't actually requested that through the short survey form. And also we do provide the copy of this session that will be the slides together with the recording just after 2 working days, so after the webinar. So just make sure that you check your inbox, junk or spam folder as well. Just before I carry on, I just want to quickly introduce myself. So my name is Perry Dikotla. I'm based in the South African office, so I look after our African market. Recently, I just completed my trip from Australia, so I'm seeing our campuses. I managed to see our Perth campus, also our Melbourne, and it was also just compelling to see our students starting their journey on campus. So they were starting their July intake. So for those who are joining us for the first time, just an overview about who we are. So when you think of EIT, think engineering. So we specialize in engineering programs. You'll see our professional development courses. You'll see our advanced diplomas, our undergraduates, graduate certificates, bachelors, masters, and our highest level of qualification at EIT is our doctorate. And yes, we are industry orientated, as you can agree with me that, time to time the industry itself is changing, technology is taking over. So at EIT, we ensure that our resources, together with our material, are still relevant to keep up with the trends in the industry. We, just like any higher education provider in Australia, our qualifications are created with Australian government. We also have some of our programs that are recognized under 3 international courts. We source our lectures from different parts of the globe. We use unique method of delivering our courses. We've got our remote labs and simulations that our students use in terms of studying at EIT. I'm just going to take this opportunity and just hand it over to Steve Mackay. Thanks, Steve.
Thank you very much, Barry, for that lovely introduction. I think we're all fired up to present. So I'll quickly introduce myself, but I'm always very impressed with Barry's wide knowledge, and he's traveled throughout the continent of Africa, and he's been to Australia, and he's certainly very passionate about the students and the learning. So thank you very much, Barry. We just need to, I'll just put the slides on. So we've got a bunch of slides here, so don't worry, we will be going through some of the key slides. I won't be going through every slide. And I'm also going to be sharing the screen for the actual AI stuff as well. So I'm a electrical, mechanical, and chemical engineer, mainly in the industrial automation business. That's been my career. And basically, I'm absolutely driven by love of learning and learning new things. And the AI has been a particularly interest area for the last 3 years now. It's certainly grown dramatically. So I'm hopeful that I can get some of the latest developments out there. But as I'm speaking to you, there will be new developments occurring. So if you have any comments, please shout or please text in the box. So on the side of the screen, you've got the box and the comments there. So really, as Barry's already given an introduction, we obviously are into bachelor degrees, master degrees, and advanced diplomas, and also micro-credentials. So we're pretty wide, operating over quite a vast area. And we obviously have a combination of online learning and campuses. So that's obviously one of our big drivers. And the online learning has obviously made us hugely aware of AI and what we need to do in that area, artificial intelligence. So that's the focus of today's topic. And obviously remote virtual labs. Everything today, as you know, is controlled through your phone or your computer. In fact, I was just looking at a demonstration. We've just taken ownership of this lovely concrete testing machine, and you cannot see a more localized lab device than a concrete testing machine, where you put a concrete sample in and you test it. But as the demonstrator said to us ruefully, he said, well, you can control this concrete testing machine anywhere in the world. All you need to do is have a little mechatronics thing to put the sample in place, which you can control remotely from Dar es Salaam, and you can have someone in London push the button to do the testing. And can you think of anything more surreal than that? So we obviously focus on our students, and this is obviously very important to us. And this is the agenda today. And obviously, as usual, I'm going to try and cram a lot of stuff in. So just quickly talk about today's objective, what we need to do about AI. I want to do a comparison between AI and machine learning, because you obviously would have heard a lot about machine learning. And then I want to cut to the chase and talk about AI and Chat GPT. And as I said, as I'm speaking, there will be new developments with Chat GPT. But I just want to talk to you and give you some heads up as to what you need to look for and how you need to skill yourself up in that area. And indeed, I'm skilling myself up every day in this area because it is changing so fast. And then really, at this point, I'm just going to ask one of our engineers, Nika, to give a quick few words about some of the AI at EIT. We don't really have much time, so because I want to look at the case studies. So she'll just say a few words, 3 or 4 minutes, just about what we're doing with AI at EIT, and then just wrap up where we can have any questions and answers. So that's what we're doing today. And obviously the idea is that you have a feeling for AI and how you can apply it to engineering. That's obviously the driver for this. Now, as I said, there's 55 slides. In the space of 45 minutes to an hour, there's no ways I'm going to get through 55 slides. So look at them as extra reading material. So please don't blame me later. We didn't go through slide number 23. It's deliberate. It wasn't random. So really what the objective of today is to look at the AI and machine learning and see how we can look at how we can apply it in engineering. That's really important. And I've got a few case studies in power and water, and I've also added one in civil as well, road building. And I just want to break our groups up at the end of my discussion of how you use the tools, and then we will have a look at each group, or we'll basically give the case studies out and then invite you to try them out. I would ask though, if you could, let me just see if I can get to the slide. It's, if you haven't got Chat GPT on your machine, there is a very easy site you can go to, which I will show you. It's got advertising on it. Hopefully no spam, but advertising. But you can actually use a browser as well. So, or if you've got Microsoft browser on your machine, you will have access to AI. So, but it would be useful to get the best value for this is to be able to do some of the exercises, which I will do shortly. So I've taken this promotional brochure or poster from Leeds University, and it says, why should you need to bother about AI? Well, basically, forefront in the future. It's just amazing what developments are out there, and a lot of them are actually giving real returns to you in engineering in your career. So that's really important. And obviously, best practice means that AI is becoming a part of the game of engineering. And you will find there's a lot of challenges in your sector of engineering, lots of issues, and AI can, and machine learning can actually help. Not completely, but can give you some support there. So I would say that AI is critical to your job career. So without any doubt, that's going to make a huge difference. We have a lot of people saying it's going to replace you. Well, as you'll see at the end of this presentation, unfortunately, that's probably not going to happen in the short term. I suspect in the long term there will be changes which I can't foresee, but at the moment it's a useful tool. It's not going to replace you as a technician, technologist, or engineer. So I think whenever I see a problem or an issue, I think of great opportunities. So whenever you have a problem coming up to face you, there's an opportunity hiding there. So I think certainly with what we're doing with AI, there are huge opportunities. So just to quickly back off a bit and say, where does AI and machine learning come into play? The sound volume is too low. I see there's a comment there. Barry, I hope my sound is okay. Is it too loud? Too?
It's all good, Steve.
It's good.
Thanks.
Okay, thanks. So Tijani, what I suggest you do is just ramp up your volume. Just turn it up. Get your boom buster, or whatever you call it, your boom box on the go, and get that sucker ramped up, and then you could probably hear me. So really what you've got is artificial intelligence. So we've got that as the overriding thing, the big box here. Machine learning you've heard about a lot over the last 10 years. That's the next sort of section, and then we've got deep learning in the middle there. And deep learning is where we've got this thing called the large language model, which is basically where the Chat GPT revolution has come from. So deep learning is a part of machine learning. And I'll explain in more detail what differences are, but effectively deep learning has made the big impact. And of course you have things such chatbots, conversational AI are all part of the deep learning model. So there's some huge opportunities there. And machine learning hasn't gone away, by the way. It's still extremely useful. But essentially, if you've got a certain amount of data, but not too much data, you probably find machine learning works just dandy, very well. But if you've got something like image processing or a huge, vast sea of data, well, deep learning is probably going to be the major solution there. So let's just have a look at the basics here. So effectively what you've got is training. You'll hear the word training. You train your data and you create an algorithm from your trained data. So that's what you do. So for example, if you've got 10,000 data points, you'll probably use 8,000 of them, 7,000 of them to actually do the training of the data. You create an algorithm and then you would test it with the 3,000 data points, and then you would have a model which you could then feed your data through and make a prediction. So very easy data through and make a prediction. So very easy to see this working, but you obviously need to create the algorithm and train up the model. And in fact, you may even need to do a comparison between different algorithms to say which is the better one for what I'm doing. So you've got quite a lot of choice, but you need to train the model up. And I'll come back to the training of the deep learning, but that's obviously was a huge task. As far as machine learning is concerned, there are three main categories. Just to put everything into context, is what we call supervised, And people often think that this is all new stuff, but in fact, I remember distinctly in the 80s, 1980, it dates me quite seriously, we were using machine learning. We didn't call it machine learning, we called it multivariate statistics. But there we had supervised statistical models, which were very effective. So effectively, there's three parts of machine learning: supervised, unsupervised, and reinforcement learning. So supervised is like email classification, classifying images, dogs and cats. If you've got a bunch of data points and then you want to find out the best line, you'll probably find supervised learning works well. Unsupervised is you've got a whole lot of data points and you basically let them group the data into different categories in an unsupervised way. You look at patterns in the data. And then reinforcement learning, I'm not that familiar with it, but if you're playing a game, chess, you'll probably find reinforcement learning goes well, where it actually gets feedback and a reward, and you can actually play chess or Go, and we've already passed beating a human, as you probably will remember. So the ones I'm really interested in are supervised, unsupervised, and obviously deep learning. So supervised learning, just to give you a few names that you hear: numerical classifiers, logistic regression, support vector machines. You have things like naive Bayes, Gaussian discriminant, so all these wonderful names. K nearest neighbors, which looks at the distance between points. So these are all supervised forms of learning. Then you've got unsupervised, and typically probably one of the most famous unsupervised ones is K-means clustering, which basically means you've got a whole lot of data points and you're basically looking for them forming patterns or groups, and you're basically looking at the distance between the points. Just bear in mind also that when I draw a two-dimensional graph here, we often are talking about n-dimensional. So we're not looking at the traditional three-dimensional or two-dimensional. We're talking about n-dimensional. So you may have a space of 100 or 300 dimensions, which obviously puts a lot of pressure on your computing. So unsupervised is the other form. And then you have dimensionality reduction issues, such as principal components analysis. Again, comes back to the idea of that the data is a vector, and you've got all these components of the vector. Gaussian mixture model, yeah, thank you very much, Hitchhiken, Mr. Gao. So principal component analysis is really when you've got a lot of data and you've got lots of columns of data and you've got all these features, age, length, height, weight, blah, 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 and then you've got a particular component here of predicting it. And you may say that there's certain of these features are more important than others, and what we use the term, they have the greatest variance, the greatest contribution. So you may find some features don't contribute anything. And one of the most enjoyable statistical analyses I did in the late 80s, as I said, that dates me, was looking at shopping center data, where you have people coming into the shop, into a massive shop, like a mall, and you look at their age, or you survey each person and you look at their age, which area they live in, their weight, their height, the kind of clothes they wear, the job they have, and you classify them, and then you can predict exactly where they will be shopping in that shopping center as a result of those features. So that's where you would look at dimensionally principal component analysis. And then you would say there's certain factors here which have no impact whatsoever on that shopping habit. So let's delete that. So that's where you look at principal component analysis. But let's move on to nearest neighbor classifier. And as I said, the idea here is this is probably the most famous one of unsupervised, which is you basically are classifying your data into two main groups here. And we calculate the distance. So we calculate the distance between them, and we decide that this forms one group. So this distance between the blue and the red there is too far apart. So we then classify these into another group with distance. So that's probably the most interesting, enjoyable one for unsupervised application. But now let's move on into the topic of today, which is, of course, deep learning, which is going one step further into those wonderful things called neurons. And welcome, LSE from Rwanda. Good to have you with us. So really, we're looking at a more interesting area, which is, of course, deep learning. And deep learning is obviously the basis of today's discussion. Machine learning is classification, feature extraction. Deep learning is where we start using things called neurons. And you may say, why? Is it similar to the brain? Unfortunately, it was called, the bases were called neurons, but they don't really have much connection to the brain, but that's naming. What can I say? But they apparently were going to be very similar. So deep learning is where you've got a vast amount of data, such as, for example, images. And the idea is that you've got an image of this and you want to analyze it. So you have low-level features, mid-level features, and then trainable high-level features like this. And the idea is that we want to analyze a vast sea of data. And of course, this is where the basis of Chat GPT is, which is what we're going to be talking about now. And you're looking at large amounts of data. So if you've got vast amounts of data, you're not going to be using traditional machine learning, and you're going to be using a neural network, this little animal here. And you will see that this neural network here has a boundary that it actually can create looking like that, which is pretty tight pattern. Whereas most machine learning, you'll be looking at sort of straight lines or perhaps a curve, but nothing as complicated as arriving from there. So for example, you want to take a handwriting recognition. So handwriting recognition, you've got something looking like this here. And we want to decide whether it's a 1 or 2. Obviously, we can see that's a 2, but if it's really badly done, it may be very difficult to recognize. So this is where the neural network, deep learning, plays a role. So basically what happens is you digitize every one of these. Deep learning plays a role. So basically what happens is you digitize every one of these inputs, x1 to x25, 256. And then we have to decide is a 1, 2, or 0, or whatever. So and then come up with an answer. So that question is, how do we take this information and convert it? And this is where we have deep learning happening in the middle here. And we have a machine here, and we have something looking like this. So basically you take your data here, each one of the pixels, 256 pixels. We then have things called weights, and we feed it through to this little box here. And we then have a bias, and we have an equation looking like this. So can you see you've got all these weights from all the different bits coming in there, and you then get an output, and you put it through a activation function. And typically, probably the most famous activation function is something looking like this. And you can then have an output and hopefully predict a 2 from that example we gave before. But in fact, as we'll show you on this next slide, you're looking at a, oops, basically what we're doing is we're giving you one neuron here, but in fact, what we would be doing is we would be having multiple neurons. You've got your inputs coming in, and we have other ones, a layer of them in the middle, and these would connect through to there, through to there, through to there, through to there, and they go to another bunch of neurons. So you have these layers of neurons, and hopefully at the end you have your 1, 2, 3, 0, 0 as an output. Each one of these connections here, these are the inputs, 256 of them, and hopefully every one of these is weighted correctly. These are the weights, and you can get an intelligent output here. Now, of course, these neural networks, deep learning, need to be trained, and the training is actually using a technique called back propagation, which I'm not going to go into here, but basically we need to train up and work out what these weights are. So what we do there is we train it up on real data. We say we should have a 2 for this particular bit of data, and you then train up the weights and the bias, as we call it there. So that's all part of the training. But as I said, you don't really need to know the details of how the back propagation works, how the training works. It's just useful to know that behind the scenes of this incredible model, you've got this training going on to try and come up with something. So what we want to look at now is AI and Chat GPT, the actual, where the rubber hits the road, where we actually talk about the application of AI. This is where it gets really, really interesting. So you've all heard about Chat GPT, well, I'm sure you have. And there's a field called prompt engineering. It's funny, whenever you want to professionalize a job, always add engineering to it, which Saga has just made a good point. Weight bias is a weight which we gave from outside the neural network to train the neural. Yep, that's right. So every neuron, you have a weight which is a bias. It's like a number you add to give it that extra bit. And then, in fact, once it goes through the neuron, you actually give it another weight, another number again on the output. So really, the challenge that we've got is that prompt engineering has come in, and everyone thinks it's going to replace humans and it's going to replace everything, but you still need a human to check the results. And the answer if you're using AI, do not try and get it to do a task which you can't do yourself, because you have to be able to check the accuracy or the result. You cannot trust the answers. It can do a lot of work for you, but you still need to be able to verify whether the answer is right. So if you can't check the accuracy or quality, believe me, you're not going to be a happy camper using Chat GPT at the moment. Okay, so the bias, Juzu said the bias said, what I'll do is, Juzu, we'll give you the slides, and on the slides we've got more detail on the bias. Unfortunately, Saga, you're quite right. Yeah, thank you very much. So really, don't use Chat GPT if you can't be sure of the accuracy or the quality. And there's recently been a case where a lawyer used Chat GPT to do a submission in court in America, and Chat GPT made up a whole lot of references which didn't actually exist, court precedents. So, and the lawyer didn't check. So of course the judge wasn't very happy. So obviously avoid using sensitive or private data, which is going to be a problem. And in fact, you'll see on Chat GPT now, they say, we won't be using your data that you're doing the testing. We won't be using that to do we won't be using it as data. So there's a huge problem at the moment in that Chat GPT has gone out and gathered all this data. And of course, the question is, who owns it? Well, if you created a website and Chat GPT's used a lot of the stuff on your website to train itself to what to do, it's arguable as to whether that's whether it's your data or whether it's Chat GPT's. I think most people would say it's my data. It belongs to me. It doesn't belong to Chat GPT. So there will be some challenges coming up over the next few years. So where's Chat GPT useful? And obviously I'm going to give a few examples in a tick, but it's useful for summarizing text. So if you've got a lot of text, you can summarize it. It can remove previous discussions, saves time and money. But you've got to remember that it was only trained up to September 2021. Now we are on September 2023. So there's 2-year gap. And of course, what happens in the middle there? Will you get any data there? Well, there's a problem there. And there's a potential bias in the data, as we know, because obviously when we do the examples later this afternoon or this morning, depends where you are, you will find that the data may not be relevant to a remote site in Australia or South Africa or UK or whatever. And the other thing is it can only cope with conversations pertaining to one topic. So if you try and have multiple topics, you won't be happy. And the other thing it does have, it has hallucinations where it just gets completely confused. So Hitchin Gale quite rightly points out the new version, the latest version of GPT-4 is built. I believe it is using more recent data, but you have to pay for it. Okay, so the formula for using Chat GPT, whether it's GPT-4 or 3, is to say, first of all, tell the Chat GPT you're a top engineer in civil engineering or electrical engineering or desalination design or renewable energy in Western Australia. I want you to design the following system. Put in recursion and then define your requirements very carefully and succinctly. Don't use spelling, don't have any spelling errors. Don't use roundabout expressions. Use strong, simple English. Okay, and Neville Funsell says GPT-4 is free if you have a 365 account. So there you go. So if you are a Microsoft fan, you will get GPT-4 free. Okay, excellent. Thanks, Nev. Nev, that's very kind of you to tell us that. And these are the following boundary settings. These are the settings. And recursion is obviously quite useful. Can anyone tell me what recursion is? Neville, what's recursion? Anuz. Juzu. Recursion? Just text it in the box, guys and ladies. You don't want to listen to me all the time. Okay, just put it in the box there. If you can text it in there, what exactly? Reinforcement by iteration. So basically what we're saying is, Mr. T there, Captain T, hello, Vern. Welcome to the team here. So recursion is basically when you tell ChatGPT, hey, I want you to tell me your thinking process. What are you thinking? Which could be a little bit catastrophic, listening to a robot, getting to the mind of a robot, but by telling it to think what its thinking process is when it does a design for you, you may actually be able to track through and say, oh, no, hang on, that's not right there. Or that all makes sense. Brilliant. So recursion is a useful thing where it actually, you say, please detail exactly what you're doing, step by step. So as far as the task description, and this is what you're going to be using now in a short while, with your task description, be detailed and specific. Don't be random, which people often accuse me of being the most random person in the world. Include all the necessary information, so be as defined, as specific as possible. If it's very general, blah-de-blah, you're not going to get a happy answer back. Also specify what you want back. I would like 400 words on the desalination in the Meekatharra aquifer for a plant I'm constructing in September 2023 or something like that. Be very careful with your grammar and spelling. It doesn't like spelling errors. Don't be ambiguous. So if you are not sure about what you're asking, don't be ambiguous. So if you are not sure about what you're asking, you're not going to get a happy answer. So if you say, mate, just go and tell me about desalination plants which I can build on the west coast of Africa, you're probably not going to get much useful answer. Be concise. So don't repeat yourself. It does hear what you're saying. If you can provide examples of what you've done in the design process, even better. Hey, this is a design of the calculation of my high voltage switchgear, 33 kilovolt switchgear. I've put in the circuit breaker settings. I'm using the ABB blah, blah, blah. And this is what I'm doing. This is the design parameters for the protection settings. I would like you to do the calculations for the next one. That's the sort of thing you want. System level boundary, you can also define what you do not want it to do and put in your constraints as well. So that also is useful. Do not give me information about this and this and this. I'm not interested. Recursion, as I said, is useful if you're not sure. It's not very good often with calculations. It's a lot better than it was, but you can also provide step-by-step reasoning why it makes a particular decision. You get far better results when you say, please give me your reasoning process to arrive at calculation value. There's a few questions there which are pouring in. Who's responsible for imposing legal, national, international law, proper use and abuse of AI tools? Is it W3C? Yeah, that's very true, Rinchin. There's actually, it's a wild west at the moment, unfortunately. The rules are not very good. So here's an example, a very simple example of Chat GPT, which I said, look, what are the steps in building a line following robot in Arduino? So it knows Arduino. It's probably a little bit shorter than you would like. And this is the response from Chat GPT. It actually gives you a fully detailed response, which is quite magnificent, actually. Gather the necessary components, design the circuit, set up the Arduino development environment, how to do that. Write the code. You can even get it to write the code for you as well. You can actually say, I want you to write the code, upload the code, assemble the robot, and test the robot. So it's quite useful written. Now, you may think it can do this for any, if it's as successful as that, it can do it for any problem or application. And unfortunately, that is not quite correct. So the first thing is you cannot trust Chat GPT. Never assume everything is correct. Do not expect precise and truthful responses. As I said, if you're not across what answer you expect, you may be massively disappointed. It needs checking. So anyone that thinks it's going to come up with an answer and it's going to be the panacea to all your problems is going to be disappointed. So please, you need to bear that in mind with the problems that we're going to be looking at shortly. So where can it help you then? Well, obviously, it can give you some simple, answering simple technical questions, electrical circuits, component budgets. And this comes from a lovely YouTube clip, 7 Ways ChatGPT Will Help Electrical Engineers. It can give explanations of a complex or difficult concept. So if there's a concept you don't quite understand, it can give you an explanation in simple English. It can give solutions to difficult problems. It can give you some troubleshooting advice. It can give you help with project management. And I've got a particular project management problem, which I'll try and show you in a tick. Latest research. Unfortunately, unless you're using Chat GPT 4, Chat GPT 3 won't give you the latest research, but Chat GPT 4 hopefully will do. And then career development, job opportunities, and obviously some suggestions on communicating and collaborating with other engineering professionals. So there's some useful stuff there. It's not high level stuff, but it's useful. So here's just a quick revision of what you're going to be doing with ChatGPT. And I just want to, again, I've mentioned most of these, but I'll just quickly revise them again. Assign a specific role to ChatGPT. You are an electrical engineer with 20 years experience in high voltage switchgear conforming to the IEC standards. Wow, that's very specific. Be specific about the task. Break your tasks up. If you've got a very complicated task, break it up into smaller tasks. Fine tune the prompts. So when you give it a whole lot of questions, you may need to keep asking to get more information. Provide it with context. You need to tell it what it's doing it about. Try and do it in small bites. You can even ask ChatGPT how to improve your prompts, and you can build up a skill that way. Don't compromise. Always demand 100% clarity and precision in the answers. You may need to change your language to get with different words. It may not be happy with a particular word, or the word that you use may not be appropriate. So you may need to try different words. Try and use the command approach. Do this rather than a roundabout approach. Be very specific. Be direct. Simple English is always the best. A lot of engineers try and write in long words, complicated words, not always useful. And then finally, define what you want. Say, I want 500 words on blah, blah, blah. So don't just leave it blank. I just want one sentence back, or I want 300 words or whatever. Be specific. Okay, so those are a few suggestions. So I just want to, you've heard my voice for the last 45 minutes. So I just want to ask our AI guru, Nika, maybe to say a few words at this point on what we're doing with, she's produced a course on electrical engineering using a little robot. And I just want to ask Nika, if you're around, maybe just to say a few words, if you can jump in at this point. I don't know if you can. Are you
Yes.
with us? Excellent.
Yes,
Thanks,
can you
Nika.
hear?
Maybe
Okay.
rather than me, Karen, can you just give us a few words? Maybe you can even share the screen if you want, if you've got anything to show, but maybe a few words about what you're doing with a course, and then we'll look at the case studies after that. Over to you, Nika.
Sure. Okay. But unfortunately, I don't have anything to share with the screen, but I can quickly discuss one way of how we use AI for education. So basically, with the advent of large language models, such as, of course, ChatGPT, we want to utilize its power to create a more interactive and engaging way of learning here at PAT. So basically, we developed an AI chatbot for our IDC video learning platform. So this is a platform that offers short video courses in various engineering disciplines. So we developed an AI chatbot. We named him Charlie, who is, of course, tailored to engage in discussions related specifically to the different lessons in the courses offered in that platform. So essentially, Charlie here is a helpful virtual learning assistant who you can ask any questions that is related to the lesson or the course. And to make the experience even more engaging, Charlie is also a pop quiz simulator. So it gives questions throughout the lesson for the student to answer. And so basically, what we want here is to make sure that the student really understands the lesson. So we developed Charlie to be really helpful by explaining the concepts properly and even asking students questions to help them understand and arrive to the correct answer. So basically, Charlie performs Socratic tutoring. So we don't want him to give out the question immediately, but rather to help the student arrive to the correct answer. And with that, we actually use our specific course data. So the first is the lesson transcript, and the second is the course manual. So of course, with ChatGPT, we want to make sure that the information being given out is accurate. So we use careful prompt engineering and validation of its answers with the help of the course manual and of course the lesson transcript. But yeah, that's basically one way of how we use ChatGPT for here at EIT.
Thanks so much. Very much
Thank
appreciated,
you.
Nika. Thank you so much for jumping in and telling there. So I think Nika's made a really interesting point there, which people probably don't always pick up. And that is that you can't just use ChatGPT to interact with the student. You're not going to be very happy with the results. So you've got to train up your bot with your own materials. So she's trained up a interacting avatar, what do you want to call it, AI animal, with a textbook. And then you train it up with that. So it's got to be specific to your particular application. So if you use ChatGPT with its millions and billions of words, you probably won't have a happy result. And one of the very famous universities in the States, Georgia Institute of Technology, they find that their ChatGPT bot was hallucinating. It was giving students wrong answers as well as good answers. So that, you know, it is a bit of a challenge. So it's not a straightforward road, but if you focus on training it up with your data, you can actually get some pretty good results. But if you think ChatGPT is going to come to the party, not quite the case. Okay, so I want to look at a few case studies, and at this point, I know we've got shortage of time, but I want to ask you out there if you can actually use ChatGPT on a few case studies. So what you're going to do is, if you have got a moment, if you've got ChatGPT on your machine, brilliant. And then what we'll do is text some of the results in the box here. But basically, if you don't have ChatGPT 4, as we had suggested, is probably the way to go. Or if you've got Bing, or you've got 365, Office 365, you'd have that available. Or if you don't have anything available, you can use this website here, talkai.info. So if you go to that website, you can actually post, or the source obviously is OpenAI ChatGPT, which I understand is now turning over $1 billion a year, which is impressive. That's US, that's not Australian dollars either. It's actually US dollars, $1 billion. That's pretty impressive after only being around for about a year startup. So you can use Talk AI to do these problems, or preferably ChatGPT. So I've got a few problems here and I want to give them out to you guys and ladies. There's 4 of them here and you can pick whichever one you want. So what you can use is, we can use a, you can use 3.5, ChatGPT 3.5. So basically what I want you to do is to look at these problems here and spend 5 minutes on them and see if you can come up with anything. So here's the first one. If you're a water resources engineering project, so you tell your ChatGPT you're a top water resources civil engineer, ask ChatGPT to help you with the following design problem. A borehole water treatment plant in a remote part of South Africa, Australia, for the provision of clean water of a community of 300 people. Select a specific location. I've said Meekatharra in Western Australia, or my favorite, Pofada in the Northern Cape. So ask it to consider the specifics and the constraints of the project, assess the response from ChatGPT, and make some suggestions to the design of the picture of the works you have created. So you can also do that one, or there's another one here, which is bridge construction engineering. Construct a bridge and I'm just putting it up there. You can, so if you want to just use your camera to capture the image like this, bang. So you've got an image of each one of these cases. So bridge construction engineering. The other one is solar energy panel design. You're a top solar panel power designer. Solar energy panel design. You're a top solar panel power designer. Ask Chat GPT to help you with the following design problem. 30 kilowatts, building 2 floors high with roof panels. Select either West Perth, Western Australia. This is a problem we've got at the moment on one of our new buildings here. Consider the specifics and the constraints of the project. Critically assess the response from Chat GPT. Make some suggestions for the design of the picture. So again, just use your phone to capture the slide. So you've got a copy of it. And then the other one is a road building project. And this one is your top road construction engineer. Ask ChatGPT to help you with the following design problem. 15-kilometer road in the Cedarburg region, penetrates a mountain, uses local materials. Consider the specifics, assess the response, make some suggestions for the design. Okay, and there's the last one there, but I think leave that one. Yep. So I leave that for the moment. So there's another one there as well, control instrumentation design. So that's for a seawater pumping station. So all I want to do is take one of these problems, give it a go, and give us some. We will give you the slides after the session. You get all the slides so you can work on it in your own time. But I just want everyone just to have a quick look at it using their Chat GPT, and then I will give you some typical solutions. I finished with the first question. Gracious me, that is so quick, Juzu. Thank you very, very much for being so quick. Just my gracious me. Jeez. Thank you very much. That's brilliant. That is, there you are. So Juzu's already got a solution to the first one. Water resources to provide clean water for community where we need to consider the following: hydrological survey, borehole design, water quality analysis, water treatment plant, blah, 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 blah. Okay, that's good. So everyone just have a look at that. Have a look at all those problems, and we will convene in exactly 4 minutes. So at 3:56, I will reconvene again, and I will go through potential solutions and some observations of what you've done. So just give it your best shot. So Barry, I just want to give everyone a few minutes just to give us their best shot, and we can then come back. Is that okay, Barry?
Thanks, Steve. And yeah, just to reiterate, yeah, so we'll be sharing the link, the QR code as well at the end of the session for everyone to request the certificate. Thank you.
Three more minutes. 3 more minutes. So Barry, I'm going to share the application screen. Okay, everyone. Barry, I'm just going to continue, otherwise we're going to lose everyone. Thank you very much, everyone, for jumping in. We've had two really great suggestions there. Juzu has put together, unfortunately, it's very constrained. And then we've got Bishesh. Thank you, Mr. Shestra, for solar panel installation. And we had the water one at the top there. So these are the solutions. So, and case two, Grace from Grace, conceptual design for a bridge. Brilliant, excellent. And we've got another one here from Solar Power Designer. Consider these. Brilliant. Excellent. So we've got quite a lot, top resource, civil engineer. We've got a huge amount of feedback. Thank you very, very much, everyone. That's absolutely marvelous. So, you know, we've got a really limited way of communicating, but you have seized the moment and you have communicated so well. So just to quickly show you what I've done, and some of those you'll get all the recordings of all the what everyone's done there, but just to quickly show you there, Barry, can you all see the case study designing a potable water treatment plant? Can you see it at the top there? Is that readable?
Yes, I think if you can just adjust it one more, just a little.
Okay, so you see the top of the screen or not really?
Not really. Let me see.
No, okay. Let me just stop sharing again. Let me just go back. Try sharing application screen again. Can you see the top of the screen now? You're a top electrical engineer?
Yes.
Okay, excellent. Okay, so everyone, you should see, I've given a prompt here. It's a very limited and it's a very weak prompt, I might tell you, but this is using Chat GPT. So I said, you're top, please give me a case study for building a potable water plant in Mackay. So I was just, so it gives you all the stuff there. And then I'll go down construction outcome. Give a detailed account of what you'd need to do in the construction phase, which is interesting. So if you see in the middle there, give a detailed account. So again, it's very short. I should be far more specific than that. So it's given its best attempt. It says certainly the construction phase of building, blah, blah, blah. So it's given some useful information there. Welding, fabrication, testing, quality control. So they're all good prompts. Now, this is interesting now. So I said, what sort of drilling will be required to get to the water? Now, if you look at it here, it's very generic. It's not, it gives you some useful information, but doesn't give you any specific information. And I finally asked the question, are there aquifers in Mackay? This is the middle of Western Australia. So it gives you some general information, but again, if you want specific solutions, it's not going to be that helpful. I've said the next thing, where should I actually drill for the water? Again, it gives you a very roundabout answer. So the point I'm making is that, you know, Chat GPT is a useful tool, but unfortunately, it can't drill down specifically to your particular problem unless you have that information on the web. And unfortunately, that's not freely available. So this information, it probably doesn't exist on the web, and it's not enough detail for ChatGPT to work with. So the point I'm making is that it's very useful to give you some general information, but when you specifically drill down for actual design information, no, can't do it. So you've got to be really aware of that. Not to say it won't be useful. It will be, but it's not as functional as one would hope. And I've got a few here. I've done another one. I did a pump station control strategy. I did pump station control strategy. I wanted some specific information there. And then I wanted to create an image. And the image is another thing which is also really in its infancy. It's the beginning. Images are also really useful, but again, not very useful from an engineering point of view yet. It will get there. It will get there, but we're still at the beginning of the whole phase. And I'll show you a few images as well, which you can create. For example, I did an image of a solar panels, and then I did one on the desalination plant, all very interesting, but not particularly useful from an engineering point of view yet. So that's basically, I'm just going to kill this off quickly, stop sharing, and let's go back to the slides, blah, blah, blah. Where's my slides, Barry? They've gone. Could you reinstate my slides, Barry?
Yes.
I think I've lost them. So I'll just share files. I'll just pull them up again. Blah blah blah. Ah, yeah, I've got them. Sorry, I've got them there. I'll just pull them up. Obviously, the app sharing, I lost the slides. I'll quickly go back to them.
It should
Blah, blah.
come up, Chris. Let me see.
Ah, thanks. Yeah, they're coming up now. That's brilliant.
Okay.
Thanks. Thanks very much. So, oops. So the point I'm making is that we've got these great case studies, but you won't find Chat GPT giving you a detailed solution to help you. So that's what you've got to be aware of. And some of you wonderful students, wonderful attendees here have come up with some really, really useful stuff, but it's not detailed enough to help you as an engineer or a technologist. And then the other thing is, you can also, I've also been experimenting with giving a nice representation in engineering design. So you do an engineering design, you want a nice representation. So for example, this one here is a copy. I want to just show you this one here. You can use this. I'm just going to share this one quickly. Sorry, I just want to quickly share this. Share. We're going to jump out of this again. Share application and bing. So you should see a little picture. Can you see the picture there, Barry? Sorry to jump around the screen like this.
Yes.
Okay, so I've given a particular example. I want a design of a terracotta house. So I've given a whole lot of information here, and it's now doing a design of this representation. So it comes up with something, and you can then pick choices here, but it's still very weak from an engineering point of view. From a showing you a general view of what you're doing, good and well, that's fantastic. But when it comes to specific stuff, it's a little bit weak still, but still it's getting there. So it's another part of the experience with AI tools. So let's go back. So in essence, just go back again to the files, share now, blah, blah, blah. Sorry to overshoot on my time, but I just want to quickly finish the last few comments here. So really the case studies, as I said, show you that there's some really useful stuff you can do, but you're going to find that it's still got a way to go to come up with specific useful information. And even the drawing, the images there, a little bit disappointing. So in essence, I just want to say, obviously, thank you very much for those that contributed their work. I know it's been it's a really tiny little screen here, but if you look at the chat, we've got some wonderful stuff coming back from VJ, Grace, etc. They've posted it in there. So thank you very much for making that contribution. But you will see, unfortunately, that all that information, it's useful background, but it doesn't give you specific enough to do your design. So we still got to do that. So in essence, it's going places, but believe me, your job is more than secure at the moment. But in saying that, You need to get skilled up in AI. You need to get familiar with Chat GPT to use these tools in helping you with your job, even if it's just as a little assistant and checking what you're doing. But do not think that Chat GPT is going to come up with some miraculous answer which you didn't know. So it's going to come up with stuff which you can check, and it'll be a useful assistant, but it's still got a long way to go before it does specific engineering designs. And if you're going to use the tool, do what we're doing. You need to train up your robot or your bot with your specific application, your textbook, blah, let me feed it in there, and then it will be able to do that task. But don't think that it's going to be able to come up with a detailed engineering design at this stage. But obviously watch that space. So that's all from me. I just want to thank you very, very much for joining in. And thanks for DataCamp. I've used some of their materials. I've attended a few of their courses. And I quite enjoy their Python course, but that's a topic for another day. So thank you very much, one and all, for joining in. And we'll just have any questions at the end. Any comments? We've got a huge amount of chat going on there. We had about 2,000 people register for this, so we'll give out the recording to all those that didn't attend. Thank you very much. We've got some really good comments here from Prayag. Probably this best thing is to email me specifically. Email Barry with any specific comments for me. I'll try and deal with them. I respond by email. Thank you so much, one and all, for joining in. A huge clap to you guys and ladies for your contribution and your work here. Thank you so much. Over to you, Barry. Thank you very much for choreographing all this and handling my erratic screen handling. Sorry.
Thanks, Steve. Thanks, everyone, for joining. So, yeah, just quickly to share our upcoming webinars. So, yeah, you can always just go to our events on the website and register. So, as I've promised in the beginning, that I'll be sharing the QR code. If you can just scan that, or you can just use the link that I just posted now in the chats in order to request your certificate of attendance. And then, yeah, we will be emailing each and every single one of you the recording together with the slides of this session. And once again, if you have any feedback, if you have any suggestions in terms of our webinar, we would love to hear that. I'm just going to quickly just post an email address that you can use in order to stay in touch with us. So you can always email our team with your suggestions and your feedback. Thank you. Thanks, Steve. Thanks, everyone.
Thank you.
I'll
really
just stick around
Barry.
just to see. Yeah, pleasure. I'll
Thank
just
you
stick
so much,
around
Barry.
to see if there's any
other questions. Thank you so much, Barry.
Yeah.
And thank you very much, everyone, one and all. Really appreciate everyone's contribution there. We will get these recordings out to you, and that everyone had put so much effort into the design questions. Thank you so much. Really appreciate it. Thank you. Cheers. And thank you, Barry. Adios for the moment.